So with this next set of notes, this is our next to last set before the test. We're looking at some of the probability rules. And the first thing we're going to do is we're just going to start out with a very simple, quick example. It says that when a fair die is rolled once, there are 6 equally likely outcomes possible. So those outcomes are 1, 2, 3, 4, 5, and 6. So use probability notation to express the probability that the die comes up an even number. So if we're looking for even numbers, we have 2, 4, and 6, and that's it. So there's 3 chances that out of 6 that it will come up even. And we can express that as P even, so that's probability even, is 3 over 6, which we know to be 1/2, which is a probability of 0.5. So that's how you express it, the probability using notation. It's going to be P of whatever the event is equal to that probability that you calculate. So one of the special addition rules is if you have 2 mutually exclusive events, which means they share nothing in common, if you want the probability of A or B, in this case, looking at the Venn diagram, then you just simply add the probabilities together and you have the probability of A or B. You can look at it right here. The probability of A or B is equal to the probability of A plus the probability of B. And you can extend that out to as many different probabilities as you want to. For example 2, we're going to apply this special addition rule of probability to determine the probability that a randomly selected farm has between 180 and 1,999 acres. So 180 to 1,999 acres falls in these 3 columns, or 3 rows right here. So what we're looking at is the probability of D or E or F, which using the special addition rule is the same as the probability of D plus the probability of E plus the probability of F. And then if we look at our table, the probability of D is 0.167, the probability of E is 0.068, and the probability of F is 0.042. So we will just add those together and we will have, let's see, 6, 7, 0.277. So the probability that a farm has between 180 and 1,999 acres is 0.277, or 27.7%. The complementation rule is going to be looking at, sometimes this is easier, this goes back to the license plate problem that we talked about. It's the probability that an event occurs equals 1 minus the probability that the event does not occur. So sometimes it's easier to calculate the probability that the event doesn't occur. Then you can calculate what the probability is that the event does occur. And you can hear my phone. Hang on. So I'm going to have to try to find where that phone call happened in the video and try to edit that out. So we were talking about the complementation rule. It's going to be equal to 1 minus the probability the event does not occur. Sometimes it's easier to calculate the probability that the event does not occur than it is to calculate the probability that the event does occur. So, and that's, you can see right here, the probability of E can be calculated as the probability of 1 minus the probability of not E. So let's look back at the farm example. And for part A, it says find the probability that a randomly selected farm has less than 2,000 acres. So when we scroll back up here to the farm values that we were given, the probability that the farm has less than 2,000 acres would encompass every column, or row rather, except for the last one. So rather than add the probability of A, B, C, D, E, and F, we can look at the probability of event G, which is that it has over 2,000 acres, and we could just subtract that from 1, and we're going to get the sum of all the values from A to F. So probability of event G is 0.0036, So we can look at probability of not G is equal to 1 minus 0.00, was it 2 or 3 zeros? 2 zeros, 36. So then that would be 0.9964. So the probability that a randomly selected farm has less than 2,000 acres is 0.9964. That's part A. For part B, it wants to know what's the probability that a selected farm has 50 acres or more. So back to our table. 50 acres or more is the last 5 rows of the table. So rather than adding 5 digits together or 5 values and coming up with the probability, we could simply add the 2 values that do not fall in that category and subtract it from 1. So it's 0.106 and 0.281. So B would be probability of not A or B, which is 1 minus the sum of 0.106, 0.281. And when we put that in the calculator, we get 1 minus 0.613. So the probability of selecting a farm at random that would have 50 acres or more is 0.613 or 61.3%. So the general addition rule is one that we touched on a little bit the other day. That's when you have that overlap. So we're talking about when we have 2 non-mutually exclusive events. That means they share something in common, and we can't count that middle component twice. We've talked about that when we did some of the probabilities earlier. So I'm going to apologize in advance if this video is chopped all to pieces. I shouldn't say in advance. About halfway through the video, I'm going to apologize if it's chopped all to pieces. It's 5:15 and my phone still rings in my classroom and people still knock on my door. So it's just been one of those days. But anyway, so I was talking about the general addition rule, and we talked about this the other day. It's where the 2 categories kind of overlap, where they have things that they share in common, and you have to subtract that out because you don't want to count it twice. An example would have been when we talked about face cards and hearts. Well, they share the king of hearts in common, so we don't want to count that one twice. We only want to count it one time. If we did the probability of a face card and the probability of kings, or hearts rather. So face cards, or let's just say probability of kings, keep it simple. It's probability of kings and a probability of hearts. That's 17 cards. Because there's 4 kings, and then there's 13 hearts. But the king of hearts is what they share in common. So there's really only 16 possibilities. So the general addition rule is expressed right here. If you have the probability of A or B and they are not mutually exclusive, then it's the probability of event A plus the probability of event B minus the probability of A and B. So that's what they have in common. So if you consider the experiment of selecting 1 card at random from a deck of 52 playing cards, find the probability that the card selected is either a spade or a face card. So again, this is a scenario where we look at how many spades there are. There's 13 spades, so we're not using the general addition rule right now. There's 13 spades, and there are 12 face cards. So we just added those together, that we would say 25 out of 52, but we know that's not right because there are 3 face cards that are also spades. So they have 3 things in common. So that's going to be 22. We'll call spades event A, face cards we'll call event B. So the probability of A and B is 22. Now if we were to do that using the special addition rule, or the general addition rule rather, It's the probability of A or B, or A and B, is equal to the probability of, that is A or B, sorry, the probability of A plus the probability of B. And if there's a weird background noise, there's a fan right above my head. I switched rooms because Steven's tutoring Sarah's daughter right now, little JoJo, so it's just bizarre. But anyway, so probability of A plus probability of B minus the probability of A and B. So the probability of A is 13. The probability of B is 12. And then the probability of A and B is what they share in common. So they share 3 cards in common. There's the Jack of Spades, there's the Queen of Spades, and the King of Spades. So when we add that together, 13 plus 12 is 25, minus 3 is 22. It's the exact same thing. This is a simplistic example, but it gives you an idea of how to compute that and how it works. The last one that we're going to look at is this example right here, where we have the data on people who have been arrested are published by the Federal Bureau of Investigation in crime in the United States. Records from 1 year show that 76.2% of the people arrested were male, 15.3% were under the age of 18, and 10.8% were males under the age of 18. If a person arrested that year is selected at random, what is the probability that the person is either male or under 18? So let's call A the event that the person selected is male. We'll call B the event that they are under 18. And we don't really need to worry about this right here, because what that is the probability of A let's see, the probability that they are male under the age of 18. So that's probability of A and B is 0.108. Okay, we take the percentage, convert it to a decimal. So the probability that the person is either male or under 18, so that's a probability of A or B, using the general addition rule, that gives us the probability of A plus the probability of B minus the probability of A and B. And we have all those probabilities, so we can quickly calculate the probability that the person selected is male or that they are 18. So the probability of event A is 0.762. The probability of event B is 0.153. And then we want to subtract the overlap, which is 0.108. We can put that into the calculator. And we get 0.807. So based on the arrest records for that one given year by the FBI, the probability of selecting a person at random who is either male or under the age of 18 is going to be right at about 81%. Those are the probability rules, some of the general ones that we're going to use in this class. This is another, I think the probability really should make a lot of sense to you guys, especially if you apply these formulas and if you try to just think about what the questions are asking. But you guys know you can ask me questions anytime if you're stuck. So I hope this is helpful. I will see you in the morning. We will get the notes for 1.15 and probably go over those in class as well. So I hope everybody has a great night. I'm getting ready to head downstairs and watch the game, and you guys have a good one.